Hello student of class 8, once again I'm Sunny and welcome back to my video. In today's video I will show you some points of the 3D shapes. So I have already made one small video before this as introduction of the chapter. So today I will show you some idea about the 3D shapes. Okay, the chapter is chapter number 10 and it is visualizing solid shapes. So what is solid shapes? You know that some of the geometrical shapes we have studied in the earlier classes or even in this time also. So for example, a triangle. This is a triangle. This is a square or this is a rectangle. So this shapes is called 2D shapes. They are called 2D shapes. Okay, 2D shapes. So triangle, square, rectangle. So they are the example of 2D shapes. They are the plane figures. They are the plane figure. They are called plane figure. They are called plane figure. They are called plane figures. Okay. So if triangle if this triangle is having some more what to say dimensions, this is called two dimensions. Once again, 2D means two dimensions. If this triangle is having three dimensions, for example, length, breadth, for example, height, then length, breadth, and depth. Some are saying that if you count from top to bottom, it's called depth. If from bottom to top, it's called height, isn't it? So therefore, height doesn't matter. If this triangle is having three dimensions, 3D, okay, it's called 3D. Then you see it has height. This is called HEIGHT, height, and this is called breadth. And let us say this is the length. If and here it has only length and breadth. Okay, length and breadth. In 2D, the shapes will have only length and breadth, but in 3D you can have length, breadth, and height. So if this triangle is having 3D, means three dimensions, then it is called solid shape. It is called solid shape. Solid shape. Okay, it is called solid shapes. Okay, if this square is having three dimensions, then you will find like this. This is a square. Okay, then you will find like this. Here, this is the square. Okay, square. Okay, so this is also called 3D shapes, and it's also called the solid shapes. The 3D shapes are called solid shapes. For example, you can see this box. This box, you can see that this is the height, length, and breadth. So this is what you can see here. The box is the 3D dimension. The 3D dimension, or it is the 3D shapes. Okay, clear? You can see here in this video, I am showing you this box. The way you see the box is 3D shapes. Okay. So if you can see only the face part, then this is called the 2D, isn't it? So what happens? This is the rectangle. So if the rectangle is having three dimensions, then it becomes the 3D shapes. Okay, it is called 3D shapes. Length, breadth, and height, and it is a solid shape. So what is this? It is a solid, isn't it? As we have studied in the science, it is solid. So this is a solid shape. Okay, the solid shapes are having three dimensions. That is length, breadth, and height. Okay. So here we can see. So a triangle with 3D shape is called prism, isn't it? Prism. And if a square is having 3D shape, then it's called cube. We call it. And if this rectangle, then it is called cuboid. It is called cuboid. 3D shape is called cuboid. You know it, isn't it? So this is also a solid shape. So my dear student, you can see here in this triangle, let us say this triangle is an equilateral triangle. Okay, equilateral triangle. This triangle is a equilateral triangle, having all the sides are equilateral triangle. So this equilateral triangle, it is having three dimensions. Then it is called a solid shape, isn't it? And it is named as prism, isn't it? The triangle. This is a triangle, isn't it? Triangle, and it's called prism. Now, my dear student, see in this prism, you can find that this side is called face. This plane figure or this plane, the flat surface is called face. So the faces are or will or they will have the same measurements. They are equal. Okay, they are equal. They are congruent to one another. See, all the faces will have the shape of this plane figure called polygon. They are the polygons. They are the polygons. They are the polygons that we have studied in the earlier chapters as they are the polygons. So this polygons here this equilateral triangle, and if it is having three dimensions, then it will be a prism. And in this prism, we will find that all the face surface are or all the faces are congruent, same, isn't it? Then this set is made up of, okay, there is another face surface there. So see, we'll find that there are 1, 2, 3, 4. So 4 faces will be there which are all equal. Okay, 4 faces which are all equal. That 3D set is called tetrahedron. Tetrahedron. It's called tetrahedron. Okay, it is called tetrahedron. Where four sides, means 4 faces will be there. For example, yes, 1, 2, another 3, and this bottom one 4. So four equilateral or 4 congruent faces. If the 3D shape is having 4 equilateral or congruent faces, then it is called tetrahedron. But what is polyhedron? Polyhedron. What is polyhedron? See, my dear students, they are called polyhedron. All these shapes are called polyhedrons. Okay. Once again, all the three D shapes are called polyhedron. I'll write here once again. What is polyhedron? What is polyhedron? The polyhedrons are the 3D shapes where they have the faces or where they are made up of surfaces which are polygons. These are the polygons. Their surface or their faces are polygons, isn't it? Yes, they are these solid shapes, prism, cube, cuboid. They are together known as the polyhedron. Here, this triangle, square, rectangle. This is rectangle. Okay. Yeah, they are the plane figure. They are the plane figures, isn't it? And they are known as the polygons. You have studied in the other chapter as they are polygons, isn't it? So, like that, in this tree, these have the faces of this shapes. Okay, the faces of these shapes are the polygon. They are made up of the faces by the polygons, means having the polygon surface. Their surface or their face. Okay, this surface or face doesn't matter. Any way you can take it. So the surface are made up of polygons. So therefore, they are called polyhedrons. These 3D shapes, which are having red like they have faces. These faces are made up of polygons, isn't it? This is polygons called the triangle, polygon called the square, polygon called the rectangles, isn't it? So their faces or their surface are made up of polygons, therefore they are called polyhedrons. And what is polyhedron? What is tetrahedron? Tetrahedrons are the 3D shapes which their faces are congruent, and number of faces will be 4 faces. The 3D shapes or the solid shapes which are made up of 4 equal or 4 equilateral faces is called tetrahedron. Okay, for example, let us say that these two are called regular polygons. Regular polygon. Regular polygon, they are called regular polygon. So their faces also will be having these shapes will be having the faces of the regular polygons. Their faces also will be regular polygons. Yeah. And these 3D shapes of these polyhedrons are made by regular. Their faces are made by the regular polygons. Therefore, they are called regular polyhedrons. They are called regular polyhedrons. Regular polyhedrons. Okay, they are called regular polyhedrons. But this is not the regular polyhedrons. Why? Because all the faces will not have the equal polygons. Means this side and this side may not be means the surface. This surface here will not be congruent. Will not be same. So they are irregular polyhedrons. Okay, regular polyhedron means the faces must have the regular polygon set. Regular polygon set. So they are called regular polyhedrons. And let us think about another regular. Yes. So if in another regular sets 1, 2, 3, 4, 5, 6. Think that this is a regular hexagon. Okay, regular hexagon. What do you say? Regular hexagon. Okay, regular hexagon. Regular hexagon, or you say hexagon. Okay, so regular hexagon and their faces. For example, let's say that their faces. Let us assume that I'm doing a very regular polygon. Okay, like this was for example. Okay, so here, see, if we just join together, fold and join together, we will get a kind of shapes. Okay, a kind of 3D shapes where all the faces are hexagon. All the faces will be a set of hexagons, also regular. Okay, clear. So if you find that all the faces are hexagon, all the faces are, so for example, let's say I will just draw once more like this here. This hexagon here. Okay, for example, like this. Some 3D shapes. Okay, let's say 3D shapes. 3D shapes, for example. This will not be, but I am just showing you. And this one 3D shapes is there. So all the faces are hexagon. All the faces are hexagon and also regular. And in this case, if you find that 3D shapes is having all the faces are regular hexagon, then that regular hexagon is known as hexahedron. Hexahedron. Hexahedron means the 3D shapes or the solid shapes its faces are regular hexagons. Hexahedron. Hexahedron. Okay, hexahedron is the 3D shapes or the solid shapes is having all the hexagonal surfaces and also regular. Okay. Now let us go to next part of the lesson. So next part of the lesson is that how we can visualize the shapes. Okay. Let us take just 1 minute. Okay. Now, my dear student, this is a solid substance, isn't it? As per your science, this is a solid. This is a solid substance. It is having shape. This shape will give you some shape of the geometrical figure also. Here you see, right here. Think that this is a solid shape. Okay. Then this is called face, and sorry, this is the front view. Okay, this is the front view. The different faces will be there. The different faces will face here, face here, face here, face here, face here. So this is called the front view. What you can see is the front view, isn't it? And this is the side view, and this is the top view. In this way, we will try to visualize it. So this visualization of the shapes or visualization of the solid shape is very useful when you try to go for mapping of some locations or some area. Okay, visualization of the shapes. Okay, see maps always giving the top views, isn't it? Or sometimes front view, or sometimes side views, or sometimes some different view also can make there when you draw the maps, when you draw the figures. Okay, for that we must try to understand or try to remember of the different views of a particular shapes or particular solid substances. Next, you see this is a box. This is a box. Yes, this is the box. Okay, clear. So this is the front view. Yes, this is the front view. In the front view, how you can see the front views. This is the side view. Sides front will be same. So any figure you can be assume as a front or side view. This is front view, side view, and this is the top view. Top. This is the top. Yes. When you keep like this is the top. Top view. How you can visualize? So this is the top view you can see, isn't it? So like this, I will show you some of the steps. For example, we have kind of figure like this. Suppose this is the some solid cells which is made up of three cubes. 1, 2, 3. Take three blocks, three cubes. Let us say this is the solid. So what happened? Here, this is the this. You see, this is the front side. Isn't it? This is the front. This is the front. Front. Isn't it? And this is the side. Side. And here is the top. Top. So how can we visualize that we will try to see? See, front view. For example, front view. how we can visualize the front of this substance. The front will be like this. I'll show you here the front view. Okay, the front view. Front view will be like this. Front view. So this is the front view, isn't it? And side view. Side view. How will be the side view? Side view will be like this. Like this. This side view. Okay, and top view. Top view. Top view. When you see from the top, you will see this face with the other face. Yeah. Isn't it? These two faces you will see, and this top view also will be like that. Okay. Otherwise, side view, actually same thing. So let me distinguish this. Side view will be this. So this is front view, top view, side view, and this is the front view. So like this, you are going to visualize the cell. Okay, in the coming up exercise also, so that you can do yourself, isn't it? For example, exercise 10.1, I am not going to do so you can do yourself because it's visualizing, and you have to match the following line. Clear? And you have to give front view or top view or side view of the given figures also. So 10.1 I am just skipping the sense that it is not important but you can do yourself. Okay. So let us try to learn about some more of the sets. Okay. So like this, my dear student, so this is a set, the solid set, and how the front view, how the side view, how the top view, we are going to discuss this. Okay. Now let us go to the next part. Mapping. What is mapping? See, mapping is very important as well as is very simple task also. See, for example, you want to sketch. You want to sketch about the whole area of your school or maybe of your house, location of your house in your town, in your cities. Then you want to sketch some part of the road, some part of the locations like cinema hall or maybe telephone towers, isn't it? Or maybe some public halls or public areas. Okay, where commonly people know your house may not be commonly known by the people, but you are going to make it easy to find, easy to locate with some kind of sketch. That is called mapping, isn't it? So mapping is very easy. Mapping work you have already done in some of those subjects in history, geography, or maybe some other political science also, isn't it? So how you did is the same way. So sometimes you map in a color to make that your mapping very attractive and very reasonable and also very informative. You make the sketch and color it, isn't it? So that color gives you more idea again. What that means, for example, the color of the trees of some forests are there in between the town or cities to make it green, isn't it? Or some kind of row of trees are there in the roadside, then you make some tree shapes and you make it coloring, or the house color, or maybe the color of, suppose pole is there nearby, so you make a pole, isn't it? Where so you make it color blue. So this coloring also giving some more informations about the mapping also. So don't forget this. You have to be make colorful of different sector or different locations of your maps. And most important is that location. The location in the map is very important. Some location that that the people will find easy to understand the area, understand the places. For example, common public places, cinema hall or public hall, okay, or maybe some I would say traffic points, okay, uh, crossing point or crosswalk point. These are some important locations that you have to put in your map. Okay, for example, if you want to sketch some area of the Ganga, C sector or D sector or G sector anywhere, then you have to give a kind of location from there. Diversion of road is there. In the diversion in the crosswalk, there is one kind of tower or one kind of post is there or some kind of stand is there, so that people understand, oh, this is stand from there, the diversion the right side or left side. Then it can find a house, can find your place easily, isn't it? So that location is very important to keep in your map. Okay. So for example, let us say that a mapping of your school coming from the geography. Okay. So let us say that this is coming from the Nahalagan. Okay. Nahalagan to Itanagar. Here you can say that like this. So this is Nahalagan. Nahalagan. Okay. Nahalagan. So you can give some area like railway station and so on. And then it's coming in. Let us say that you reach the 0 point. 0 point. Here one diversion is there, isn't it? 0 point. So you can make here some shops. Okay, some shops here. One mandir. Suppose mandir. I mean temple. Okay, temple like this. So this is Radha Krishna. Radha Krishna mandir, isn't it? Radha Krishna mandir. We have one location. People used to visit there, isn't it? Then next, you can have one kind of big buildings here like this. Okay, so this is Hotel Sugan Cities, isn't it? Then one road, this road, you can just say that it is to museum, isn't it? Museum, state museum. Division. And from there, one diversion, you can say that this diversion, here Gompa Mandi is there, isn't it? Gompa Mandi. Gompa Mandi. And this arrow will lead to your school, Tonipur, for example. Tonipur. And you can just make kinds of curve here. You know, the road is not this one. Not straight, so curve. So this arrow must be continued. Okay, then your Manipuro gate will be here, isn't it? Manipuro gate will be here. Yes. This is the DPP, DPP, DPP mandate, for example. Mandate. Here we start, like this. And then here, hostels, city, is it hostel? This is hotel, okay, this Suban City Hostel. This is Suban City Hostel. Suban City Hostel, okay, like this. And here, playground like this. So you can just canteen here, school canteen. Like this, you just can give mapping there, and you can just give the color also. Okay, Upamandi. Upamandi, how you can work with Upamandi is like this, isn't it? Something like this, so Upamandi like this. So this is, you can make some green part here, like some woods, I mean forest. Okay, forest, some forest plants. So you can make it. So this is called mapping. So mapping, actually in mapping what is important is that the location, the way the public used to visit commonly, the common place of the public. Okay. For example, Gopa Mandi, Alexandra Mandi, for example, we have this location here, isn't it? Through there only that people will be able to find our Unipolo main campus. The Unipolo main campus will be there. So when you are making, isn't it? Like this, we can go through. So mapping also very simple. Here some questions are there about the mapping, so you try yourself to do that mapping. Okay, clear? So then let us go to the last point of this chapter. The last point of the chapter, that is Euler formula. Euler formula. Okay. Euler formula. Euler's formula. Euler's formula. I guess that to learn the Euler's formula, so we are going to come back against in some points of the 3D sets. For example, you see here one 3D sets here in the ground where there is no surface, flat surface. They don't have flat surface. They have surface, but they don't have flat surface. For example, sphere. Isn't it? This is sphere. You know what is sphere? Yeah, sphere is the 3D shape of the circle is called sphere, isn't it? So sphere we will have here, and if it is divided into two parts, two equal parts, the sphere, and it is called hemisphere. Hemisphere. Okay. If the sphere is divided into two equal parts, then its part is called sphere. In the circle, it is called semicircle, isn't it? Yes, in the circle, it is called semicircle, but in the sphere, it is called hemisphere. We don't say it is semicircle, okay? It is hemisphere. Now, let us say that some of they don't have face, okay? See, this is cylinder. This is cylinder, and this is called the face, okay? Face, that part, face, okay? They call face, and this is called lateral surface. Lateral surface. Lateral surface is the curved surface. Curved surface. It's called curved surface. Okay. Lateral surface is called curved surface. Here also, for example, this is cone. This is cone. Okay, this is called cone, isn't it? This is called cone. This is also called lateral surface. Lateral surface. Okay, and this is called the flat surface or equal face. So this face will be known as base again. Okay, it is another face, but it is called as base. So this is also called base. Lateral surface, base, base. This is also called B. Not C. This is B A S A, base. Base. Here also base. The faces will be named as base in such type of figure, cylinder or cone. Okay. Sphere, once again, sphere is the 3D shape of the circle, and if the circle is divided into two parts, we call it semicircle, but in the sphere is called hemisphere. Don't forget this. Okay, clear? And somehow I will try to show you. See, for example, this 3D shape here, we have already come across of this point in my previous video. Okay, see, this is a solid shape. So this solid shape has three dimensions. One dimension is called length, isn't it? Length, and this line is called breadth. Breadth, isn't it? And this one is called height. And then it is become the solid shapes or 3D shapes. But in this shape, what I will tell you is that, my dear student, In this solid set, this flat surface, okay, this flat surface is called face. Okay, and this, all this flat surface of the solid is called face, and then this line is called edge. Edge. X. This is F. And then can you see that the edges are joining in some points, isn't it? Yes. They are called vertex or vertices. They are called vertices. They are called vertices. All together vertices. Single is called vertex. Okay, in singular is called vertex, but plural they will be many, isn't it? So this is called vertices. Vertices. In plural it is called vertices. Singular is called vertex. So faces, many faces are there, isn't it? 1, 2, 3, 4, 5, 6. 4 faces will be there. Up one, down one, six. 6 faces are there. So here now we will come to the point of this Euler formula. So many solid substances are there, solid shapes are there, or many shapes is called polyhedrons. So many polyhedrons are there, many type of polyhedrons are there. So for a given polyhedron, how many faces will be there, how many edges will be there, how many vertices will be there, that we can find out. We have this Euler formula, and my Euler formula is saying that F plus V minus E equal to 2. So this formula is very important to learn this formula to find out the number of vertices, number of faces, number of edges. Now let us try to understand this. This is a cube. This is a cube. Cube has many faces and many vertices, many edges. How many vertices will be there? How many edges will be there? Face, we know that face, how many face, how many are there? Face we got is 6 face, isn't it? Plus, how many vertices will be there? Vertices we don't know, isn't it? Yeah, let us say vertices. Let us find out for this one will be there. Okay. Without this, just one minute. Let's try to find out how many vertices are there. Okay. So 3D cells. So on the other side, some edges will be there like this, isn't it? Some edges will be there. Can you see one over here? Yes. And how many vertices? Let's count out. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices are there. Minus how many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges are here equal to 2. Let us see this correct or not. Okay. So you see on this side, left hand side, okay, is equal to 6 plus 8 minus 12. 6 plus 8, how much is there? It is 14 minus 12 is equal to 2. That is equal to right hand side. Yes. All this number of faces, vertices, and the number of edges are correct. Okay, because the number that we are getting from here is satisfy this Euler's formula. Then yes, the given number of faces, the given number of vertices, the given number of edges could be a polyhedron. This is what we have to do in the next coming up exercise. Okay. So here, so let us try one more again. So this okay. Uh, Such type of number of faces, vertices, and edges is possible to have a polyhedron, isn't it? But some more. Let us say that face equal to 5 and B is equal to, let's say, 8 and E is equal to 13. Let us find out, will this be a possible polyhedron or not? For that, we need to apply the formula. What is the formula? Euler formula, isn't it? Euler formula. So in Euler formula, I think that face was 5 and plus vertex is almost 8 minus this one. 8. How much? 8 something, isn't it? So let us see whether this left hand side is equal to right hand side or not. Equal to 5 plus 8 minus 13, isn't it? That means 5 plus 8. 5 plus 8 is equal to 13 minus 13, isn't it? That means 0. But it is not equal to right hand side. Then there is given information about the faces, vertex, and edges is not possible for any polyhedron. Like this, we are going to give the answer to coming up exercise. And my dear student, with this, I come to the end part of today's session, and exercise I will show you in the next video. Okay. So till then, have a nice day, and thank you once again for watching my video. Okay. Bye bye. See you again.